This is going to be 8.2, sine and cosine functions. So here is where we're going to actually define a couple functions that relate to everything that we've been talking about with radians, degrees, right triangle trigonometry, and all that stuff. So I'm going to start off with the definition. So let x and y be a point on the terminal side of an angle of theta radians, okay, in standard precision. Okay, and let r be the distance from the origin, okay, so we define sine of theta and cosine of theta as follows. Okay, so sine of theta is equal to y over r, and cosine of theta is equal to x over r. So this is really important. This is something that you should know. Okay, so we are defining two different functions, the sine of theta and the cosine of the theta. Okay, so the way that we write this, sine, so here we have sine, the sine of the function, and the cosine of the function. So the way that we write sine, we basically get rid of the e and we just write sine, and then followed by the angle, so sine of theta. This cosine, we get rid of the I and e, and we write cos, and we write theta, okay? And they both equal to their respective formulas, y over r and x over r, okay? So basically, when we're talking about the sine and the cosine, we are basically relating the lengths of some particular segments with theta, okay? So let me give you an example. So let's say we have the x and the y-axis right here. So here is my x and here is my y, okay? Here is my line segment. I'm rotating it to some point x comma y, and then you are rotating this theta radians. Okay, so basically what this means is that if I have this line segment, it has a radius of r, then basically what this is saying is that if I want to figure out what the sine of the function is basically going to be the y value, whatever this y value is, divided by the r. Okay, if I want to figure out what the cosine of the function is, I'm going to take the x value and I'm going to divide it by the r. That's basically what it is. So if I were to draw like kind of like a triangle, like if I were to draw a little triangle down here, 90 degrees, we know that this whole side right here is going to be my x value because it's in the x-axis. So this side is going to be x, and this side over here is going to be my y, okay? Okay, so that whole thing is my y. So you can kind of imagine that r here is just going to be the Pythagorean theorem. So if I think about it, let me write it this way. I know x, y, and r, then x squared plus y squared is equal to r squared. If I take the square root, r is equal to the square root of x squared plus y squared. Okay, so basically if r is not given to me, I can go ahead and figure it out that way. Okay. Notice also if r is equal to 1, then the sine and the cosine is just going to be equal to the y and the x value. Okay, so let's first start off with doing an example. Let me choose this color. Okay. Okay, so find sine of theta and cosine of theta. Okay, and here is my question. So I have this thing, okay, and this is going to be theta is going to be equal to, let's just say this is just theta, and let's say this point is going to be 1 comma 2. Okay, so this is a point 1 comma 2. Okay, so we want to find the sine theta and we also want to find the cosine of theta. Okay, so the first thing to note is that we know that sine theta is going to be equal to y over r, and the cosine of the theta is going to be equal to x over r. Okay, so now do we know what x and y is? Well, yeah, we do, because that's just the coordinates. This is going to be my x value, this is going to be my y value. Okay, so in this case, x equals 1 and y equals 2. Do we know what our r value is? Well, not yet. Our r is going to be the distance from here all the way to here. How do we find the distance? Well, we just figured out this formula right here. So the distance is going to be r is equal to the square root of x squared plus y squared. So this is going to be the square root of 1 squared plus 2 squared. So you're going to get 1 plus 4. That's going to give me 5, square root of 5. Okay, so now we can go ahead and plug everything in there. So let's first start off with the sine of theta. Okay, so the sine of theta is going to be equal to y over r. Y in this case is equal to 2. Okay, and r is equal to square root of 5. Now, I do not want it like this. I want you to rationalize it. What rationalizing means, back in algebra, we wanted to get rid of the square root, so we're going to multiply it by the square root. So we don't want a square root on the bottom. So what we're going to have is 2 square root of 5 divided by 5 times 5 gives me 25. The square root of 25 gives me 5. This is how I want it. Okay, 2 square root of 5 over 5. Okay, and then what's going to be the cosine of theta? Well, the cosine of theta is going to be the x over the r. X in this case equals 1 over square root of 5. I'm going to multiply it by square root of 5 over 5, so there's no square roots on the bottom. So it's going to give me square root of 5 divided by 5. Okay, and that's just basically it. Okay, let's do another problem. So let's say, now, whoops. So let's say now we want to figure out what this is going to be. So let's say this is going to be -3, -4, and then all of this is going to be the angle theta. Okay. So what's going to be that sine? So we're still finding the sine and the cosine. Okay, so sine of theta is going to be equal to y over r. The cosine of theta is going to be equal to x over r. Okay, so now let's first start off by finding what r is, because we know what our x and our y is. Our x in this case is going to be in this -3. Our y is going to be equal to -4. Okay, so our r is going to be equal to the square root of x squared plus y squared. That's going to give me the square root of -3 squared plus -4 squared. This is going to give me 9 plus 16, square root of 25, which gives me 5. Okay, so r is equal to 5. Okay, so we know our x and our y's. Now we can figure out what the sine and the cosine is. So sine of theta is going to be equal to y over r. Y over r is just equal to -4 over 5. That is a sine. Okay, now what is the cosine? The cosine of theta is going to be equal to x over r. X in this case is going to be -3 over 5. Okay, and that is my answer. Okay, all right, so not too terrible. These problems are not really too difficult. They're very, very much of the same, other than just rationalizing when there's a square root on the bottom. But now let's do a couple other problems, because usually theta is going to be given to you later on. But let's first start off by finding the angles themselves. Or if given an angle, can you figure out what the left-hand side is going to be? Okay, so let's do this one. Okay, so find the sine of theta and cosine of theta for theta equals 0, pi over 2, pi, and 3 pi over 2. Okay, so let's figure out what that is going to be. Okay, so first of all, let's try to figure out where 0, pi over 2, pi, and 3 pi over 2 is. Okay, well, let's first start off with 0. Okay, so theta equals 0. Well, theta equals 0, well, we all know where that's at, okay? Theta equals 0 is going to be right here. Okay, so in this direction. Now in this direction, we have so many points that we can choose from. We can choose any point that we want in here. And any point that you want to choose, it's going to give you exactly the same thing. So what I would choose the easier point, which is going to be 1, 0. Okay, I think that's probably the easiest one that we can probably use. Okay, so what we're going to do, we're going to try to figure out what the sine of 0 is and what the cosine of 0. Okay, so because we know that this is going to be x over y, this is going to be x and this is going to be y, okay, r in this case is going to be the square root of 1 squared plus 0 squared, which is just going to give me 1. Okay, so the sine of 0 is going to be y over r. Y in this case is equal to 0 over 1, which is going to give me 0. Okay, so the sine of 0 is going to give me 0. The cosine of 0 is going to be the x over the r. That's going to give me 1 over 1, which is going to give me 1. Okay, so that's what the cosine of 0 is going to be. Okay, that is for theta equals 0. For theta equals pi over 2, okay, let's do the same thing. So pi over 2, if you were to convert this into radians, this is actually 90 degrees. Okay, so if you want to think about it, that's 90 degrees, pi over 2. Okay, so pi over 2 is going to be right here. Theta equals pi over 2. I can choose any point along this angle, along this line. I'm going to choose the same point, kind of very much the same, but in this case, it's going to be 0, 1. That's a point on that line. So now we want to find what the sine of pi over 2 is going to be and what the cosine of pi over 2 is going to be. Okay, so in this case, what is r? R is going to be the square root of x squared plus y squared. That's going to give me, that's going to be 0 squared plus 1 squared, which is just going to give me 1. So sine of pi over 2 is y over r. Okay, so y in this case is going to be equal to 1 over 1, which gives me 1. Okay, the cosine of pi over 2 is going to be the x over the r. That's going to give me 0 over 1, which is going to give me 0. Okay. Now let's do the last two, which is pi and 3 pi over 2. So theta equals pi. Okay, so here is going to be pi. If I were to convert this to degrees, this is just equal to 180 degrees. Okay, so we're basically theta equals pi is over here, okay, along this line. Okay, so pick a point. I'm going to pick negative 1, 0. Again, you could have used any point that you want, negative 2, 0, negative 7, 0, negative 100, 0. You still would have gotten the same thing. This is going to be our x and our y. R is equal to the square root of x squared negative 1 squared plus 0 squared. That's going to give me 1. So now let's figure out what the sine of pi is. So the sine of pi is going to be y over r. It's going to give me 0 over 1, which gives me 0. Okay. Similarly, the cosine of pi is equal to x over r, which is going to give me negative 1 over 1, which is going to give me negative 1. Okay, so that's the cosine of pi. Okay, and now let's do the last part, which is going to be when theta is equal to 3 pi over 2. And in this case, this is 270 degrees. Okay. So here is theta is equal to 3 pi over 2, which is going to be this direction. I'm going to choose another point, 0, comma, negative 1. This is our x and our y. Figure out what your r is. That's just going to be 0 squared plus negative 1. Still going to give me 1. Okay, so now the sine of 3 pi over 2 is going to be equal to, well, let's go ahead and plug this in. So it's going to be y over r, negative 1 over 1, which gives me negative 1. And then the cosine of 3 pi over 2, that's going to give me x over r, which is 0 over 1, which gives me 0. Okay. Okay, so this was a lot of work, but notice that it's exactly the same thing. And yes, of course, if you go to your calculator and your calculator actually does have sine and cosine. Now, one of the things that you have to be able to do is that make sure that your function or your mode is in radians, and I'll do a video on how to convert from radians to degrees. But yes, your calculator will do these problems by um, really really easily, but in for an exam you would want to I want to show me all of these, and I'll also show you a different way to do them, and also deriving something called a unit circle. So in the next video we'll do a couple more problems like this that maybe might be a little bit more complicated.